Hey folks, welcome to this episode on empirical formulas. So in this first episode, we're going to look at the basis and the theory behind empirical formulas and molecular formulas, as well as distinguish some of the differences between these two formulas. So we have some guiding principles. The first ones are really the ones that we're going to focus on when trying to deduce the empirical and the molecular formulas. The first one that you may have heard about before is the law of conservation of mass. And this law of conservation of mass basically states that mass is neither going to be created nor is it going to be destroyed. And so this is going to come into one of the first steps when we start calculating our empirical formulas. The second one that is going to be guiding us is going to be the law of definite proportions. Now, this law states that a compound contains the same proportion by mass of its elements. What this means is that when we're looking at one element, for example, if we look at something like H2O, H2O, no matter where it is in the world, is always going to be created with two hydrogens to one oxygen. And we are going to be using this ratio to help us create our formulas going forward. So the main question is, what is the difference between an empirical formula and what's the difference between a molecular formula? So the empirical formula is typically the simplest whole number ratio of the elements in that compound. So it shows a relative proportion of the elements. It doesn't necessarily show the actual number of atoms. And so this is going to be our most reduced form of the formula. For example, if we have something like hydrogen peroxide, H2O2, this right here represents our molecular formula because this is the actual formula of hydrogen peroxide. However, what we can see is that this is a ratio of 2 to 2, which can be simplified to 1 to 1. And so if we're looking at this most simplified form, we can convert this formula into HO, and this would be our empirical formula. Okay? Now, this formula doesn't actually exist because, as we know, the oxygen can form two bonds and it can't form a double bond with hydrogen, so it doesn't actually exist. Now, that's not to say that all empirical formulas don't exist. There are some that may exist. For example, H2O. That's an empirical formula. You cannot reduce that any further, and that does exist. We know that as water. And so what we're going to try to do is we're first going to try to deduce our empirical formula using the law of definite proportions to determine this ratio between the atoms. Then we're going to compare it to the actual mass of the formula we're looking for and find its actual identity. And that would be the molecular formula. Sometimes, as we mentioned, that empirical formula that we find will actually be also our molecular formula going forward. So again, a molecular formula is the actual number of atoms that exist in that compound. It is not a reduced form, and it's some kind of multiple of our empirical formula. Whereas our empirical formula is going to be the smallest whole number ratio. So in this particular case, benzene, you would see you can count all the atoms. We have C6H6, and what we can see is that we have a 1-to-1 ratio here, and so our empirical formula would be CH. So take a look at these different examples. What we can see here is different examples of formulas and what their empirical slash molecular formula is going to be. So in water, for example, we have H2O. You can see that the empirical formula is the same. It cannot be reduced. It's already in its lowest format. Whereas if you see something like propene, you can see that we have 3 and 6. So this would be a 3 to 6 ratio, or we can reduce that by dividing by 3 or factoring out the 3 to a 1 to 2 ratio. And so if we say that this is C1 and H2, if we simplify this, we will get CH2 as our empirical formula. So again, not everything can be reduced. There are going to be some instances like water where it's already in its most reduced format and it is a real molecule. But there are going to be many that can be reduced into a simpler whole number ratio, being its empirical formula. So pause the video and try to answer these questions. You have 3 questions, and let's take these up in a moment. All right, welcome back. Let's see how you did. So the empirical formula for C4H8, well, again, we have a 4 to 8 ratio, which we can simplify or reduce, excuse me, into 2 to 4, which we can further reduce into a 1 to 2 ratio. So we have one carbon and two hydrogens, and that would be CH2, which is going to be B. Now in this one over here, we have an 8 to 14 ratio. Now, on the onset, it doesn't look like we can really reduce this number quite a bit, but what about if we factor out a 2? What we can get is we can factor out a 2, we would get 4, and we would get 7. Now, looking at what we did in the first question, can we reduce this any further? We cannot. We cannot reduce this and get a whole number, so this is going to be our empirical formula. We're going to have C4H7. And the last one was a little bit of a trick. What is the molecular formula for CH2O? Remember that a molecular formula could be any multiple of an empirical formula. We just don't know what that multiple is unless we find the molecular formula mass. We need that mass in order to tell us the identity. And so this really could be anyone's guess. You could take this, you could say that this is actually the molecular formula, and it does exist. We have something that looks like this. All right. So this is actually a molecular formula as well. You can multiply this by 2 to get C2H4O2. That's option B. Or you can multiply this by 3, 4, 5, whatever it might be, and you can get various options. We don't know what it is without the mass of the molecular formula. So that's something that we're going to bring into as we go and explore how to calculate this. So please take a look at the next video. It's going to be on calculating empirical formulas. And then the video following that is also going to be about calculating empirical formulas that don't really line up with what as cleanly as we want it to be. Thanks very much for watching. Hope you found this helpful. See you next time.